Here are your solutions to Chapter 4, Lesson 6. Lesson 6 is about constructing functions. So let's take a look at our first table here. Analyze graphs, words, and tables. Basically all this is talking about is the fact that we can use the initial value of a function, and the initial value of the function is the y value when x equals 0, or in other words, the y-intercept. That's what initial value means. I would definitely make sure I put that in my notes if I were you, and on your gold sheet. You can find the initial value of a function from a graph. You can do it with words, and you can do it with tables. Again, we're looking for the y-intercept. So let's take a look at problem number 1. A shoe store offers free points when you sign up for the rewards card. Then, for each pair of shoes you purchase, you earn an additional number of points. The graph shows the total points earned for several pairs of shoes. So it's going to be points per pair of shoes. I'm just going to use the word pair. And we're writing off to the side so it's not showing. Pair. Points per pair. Here we've got points, and here we have pairs. And it asks us to find and interpret the rate of change in the initial value. So we're going to put rate of change over here. And we're going to put initial value. And initial value is the y-intercept, and our rate of change is our slope, which we're very good at finding in both cases in a graph like this. So the first thing we need to do is find the slope. Well, remember, all we need to do is do our rise over our run. Right here is our rise, and right here is our run. So if we take a look at our scale here, we can see that the rise was from 60 to 90. So we just need to do 90 minus 60. And our run is from this line to this line. And if we look at those numbers down here, that's from 4 to 2. So 4 minus 2. So we have 90 minus 60 is 30 over 2. And that, of course, is a slope of 15. So our rate of change is 15 points per pair. So it's 15 points per pair. We'll put that over here. That is our rate of change. So we've answered the first part of this. And then the initial value. Taking a look at initial value, we can do the same thing we did. We recognize that this was a rise of 30 and a run of 2. So another way to look at this is from any given point. Let's say this point here, we could drop 30 and go left 2, and we would be at the next point. So if we start right here and we drop our 30 and then move left 2, we can see that we end up at the point where we have 30 points is our initial value. So we would have an initial value of 30 points, and we talked about that we had 15 points per pair was our rate of change. And if we take a look at our math down here, that's exactly what they were looking to show us. Right here are our calculations for the 15 points per pair, and then they did the initial value, or the y-intercept, slightly differently than I did, but you could take a look at this. Do what works for you. Continuing the graph is a very easy way to do it. Please press pause and do letter A. Alright, let's take a look at problem number 2. Joan has some photos in her photo album. Each week she plans to add 12 photos. So I would write that over here. We're going to do 12 photos each week, so that's per week. So immediately you should think that this represents a slope. Joan had 120 photos after 8 weeks. Assume that the relationship is linear. Find and interpret the rate of change and the initial value. Well, first of all, the rate of change I think was quite simple. The rate of change is 12 photos per week. So we're going to have output equals slope times input, and then we're going to add B. Remember, B stands for our y-intercept. That's one of the things we're going to be looking for. So we have output and input and slope. Well, immediately we thought our rate of change was 12 photos per week, so we have that. We're going to multiply that by the input, and we're going to get the output. Well, they already gave us an input and an output. They said that Joan had 120 photos after 8 weeks. So if you think about that, 120 photos would be the output, so 120 equals 12 times 8 plus our intercept. So we've got the slope right here, rate of change. Now we're going to do our math. We have 120 equals 12 times 8 equals 96. So we have 120 equals 96 plus b. So we are going to subtract 96 from both sides. The variable here is telling us to do that. We have our zero pair here. We have b equals 24. So we now have the two things that they wanted. We can take a look at it over here, and they can show how they did this very similarly to what I just did. We have a y-intercept of 24, and that is what the initial amount of photos is. Since each week Joan adds 12 photos to her album, the rate of change is 12. We get that strictly from the words. 12 photos per week, this becomes the rate of change, and then like I showed you here, we can put that output and input into our equation and solve for the initial value. Please press pause and do letter B. Problem number 3. The table shows how much money Ava has saved. Assume the relationship is linear. Find and interpret the rate of change and initial value. Well, the rate of change should be simple. Because it's linear, we only have to check one cell, so we have a change of +1 here and a change of +20 here. So our rate of change, or our slope, remember, is dollars, and it's $20. Right here's where I get dollars from, per month. $20 per month is our rate of change. So there's our first answer. And then it asks us to find the initial value. You can find the initial value one of two ways. First of all, to find the initial value, use the slope-intercept form to find the intercept. So we can say y equals mx plus b. So we have y equals 20, because that is our rate of change, times x plus b. And then we can take one of the values from the table here. We have 110, that's our output, equals our input of 3 times our slope of 20 plus b. So we would have, let me finish the math over here that they didn't do, 110 equals 20 times 3 is 60 plus b. We subtract 60 from both sides. And we have 50 equals, this is a zero pair, equals b. That's one way to do it. Another way to do this would be to work backwards from our table. We can move back here. I'm going to put the numbers down here so that you can see better what I'm doing. So we had a 3 here and a 110 here. Well, we could move back from 3 to 2 to 1 to 0 and find out what this value is. But we don't even really have to fill in these two values, because we know that we're adding 20 in each case. So we're going to subtract, so this is a 110, we're going to subtract 20, 40, 60. So 110 minus 60 equals 50. This is a little bit more physical representation of doing it. If this works well for you, great, then use it. If this way works better for you, then go ahead and use the algebraic method as well. Please press pause and do letter C.